Today, let's talk about the coal-forming environment. The coal-forming environment has a massive impact on the technical properties of coking coal. While many parameters are affected, they essentially depend on three primary elements present in the environment at that time: oxygen, carbon, and hydrogen. Throughout Earth's history of coal formation, carbon and oxygen have always existed in an inverse relationship. When carbon dioxide is high, the coal-forming environment is dominated by a reducing atmosphere. When oxygen is high, the environment tends toward an oxidizing atmosphere. From the beginning of coal formation until today, there have been three major coal-forming periods: the Carboniferous Permian, the Jurassic, and the Tertiary, along with several minor periods. At the start of each period, carbon dioxide levels are typically very high. During the coal-forming process, carbon dioxide is continuously consumed and sequestered underground as coal. Simultaneously, plant photosynthesis generates oxygen, causing oxygen levels to rise steadily. This chart illustrates the shifting trend of the carbon-oxygen environment during the Carboniferous period. At the onset of the Carboniferous, carbon dioxide concentrations were approximately 20 times higher than today. Oxygen levels were significantly lower than current levels. The coal-forming process saw a transition from very high carbon dioxide to low carbon dioxide, and from relatively low oxygen to a gradual increase in oxygen. The coal formed during different stages of this process exhibits distinct variations. Let's move to the next diagram to see how these changes occurred. This period, shown here, represents the stage of large-scale coal formation during the Carboniferous. Using Taiyuan Xishan as an example, this corresponds to seams number 8, number 9, and number 11. Because carbon dioxide was high and oxygen was low during this time, the resulting plant matter was not easily or immediately oxidized. Furthermore, plant growth was exceptionally rapid, leading to massive coal accumulation. By the late Carboniferous, we reached a new stage. At this point, a vast amount of carbon was either buried underground or held within massive surface biomass, such as forest vegetation. This caused carbon dioxide concentrations to drop significantly, even lower than today's levels, while oxygen levels rose much higher than today. Consequently, the Earth entered a strong oxidizing environment. During this period, all coal-forming land masses experienced widespread forest fires. Geologically, we refer to this as the Carboniferous Rainforest Collapse. As a result, coal formed during this era contains a very high proportion of fusinite. Fusinite forms when dead plant matter is either exposed to an oxidizing environment and oxidized, or when forest fires turn it into charcoal. Taiyuan Xishan Seams number 4, number 5, and number 7, for instance, are characterized by high fusinite content. After this environment ended, the overall decrease in carbon dioxide led Earth into a relatively cold historical period, the Permian Ice Age. As massive amounts of water were stored as glaciers on mountains, sea levels dropped rapidly. The coal-forming environment shifted from low-lying marshes to raised bogs. Low-lying marshes, typically located at or below the water table, produce coal with higher hydrogen content and abundant algae. In contrast, the raised bogs of this later environment produced coal with a high oxygen content. Taiyuan Xishan Seams number 1 and number 2 were formed during this period. To summarize, coal formed during the early stages of a coal-forming period possesses superior caking and coking properties. For example, Carboniferous coal from Xiangxi's Puxian typically has a Y value over 10 μm, higher than Permian coal of the same rank from the Hedong-Liliu mining area. As for the coal formed during the rainforest collapse, such as Xishan Seams number 4, number 5, and number 6, their performance during the coking process is significantly inferior compared to both the early Carboniferous and Permian stages.